Moving on here to day 2. Day 2, we did the easy graphs like this. Now we're going to do the more difficult ones. So basically what this does, on the outside, it moves it down 3. So that's going to affect my range. My domain is still going to be all real numbers. My range is moved down 3. So instead of being y bigger than 0, it's going to be y bigger than -3. Now when I go to make my XY chart, I'm going to include -1, 0, 1, and 2, and plug numbers in. So then when I do this, I'm going to plug it into my calculator. -1 minus 1 is -2. So I'm talking 2 to the power of -2. Then I'm going to times that by 4 and subtract 3, and my calculator should give me -2. 0 minus 1 is -1, so 2 to the power of -1. I times that by 4, and then I subtract 3 and it gives me -1. 1 minus 1 is 0. 2 to the 0 power is 1 times 4 minus 3. 2 times 4 is 8, minus 3 is 5. So these should be their 4 coordinate points that you get. So -1, -2, 0, -1, 1, 1, and 2, 5. Just like that. Same thing with the next one. If I want to graph that, I'm going to do all real numbers, and then this means that y is greater than 2. So that when I go to make my XY chart, let's do -1, 0, and 1. Hopefully we can get it from there. There we go. When we plug in numbers into that thing, when you plug in -1, hopefully you get 5, 3.5, and 2.75. If you're having trouble with this, please come see me and I'll show you how to plug it into your calculator. But -1, 5, 0, 3.5, 1, almost 3, and it goes like that. Next part, compound interest. So we have this nice formula here. It's when interest is paid on the principal and on the previously earned interest. This is good. When you put money into the bank, you want interest to accrue and whatever you've earned to accrue. Accrue just means make money. So P in this equation means amount of money I'm putting in. N here, we got it twice in this formula, is my number of times compounded per year. R is my rate, that's my percentage, and T is my time in bank. My time in the bank. So those are the 4 things you need to know for that formula. Flip it over. I'm going to write the formula right at the top here. I'm going to zoom out. There we go. So my formula is P, and then I have 1 plus R over N to the power of NT. So, putting $5,000 in an account that pays 4% annual interest, find the balance after 6 years if the interest is compounded annually. So, here's my amount I'm putting in. I'm putting in $5,000. My rate is 0.04. How many times is this thing being compounded per year? Annually means 1 time per year. Your birthday comes annually. So that's the same thing up here, 1, and then how many years is this thing in the bank? 6 years. Let me show you how to plug this into your calculator. So if you look, what's the best angle here? Like that maybe? Okay. I would start with this. So I'd do 0.04 divided by 1. I know that's an easy one. And then I add 1, whatever's in this parentheses. Then I take it to the power of 6, in this case, and then I multiply by the outside number. And in the end, I should get $6,326.59. Hopefully you got that when you plug that into your calculator. You deposit $5,000 in an account, same thing. 4% interest, but this time it's compounded quarterly. Quarterly means 4 times a year. So that means my end value changes to 4, still in the bank for 6 years. So plugging this in, I do 0.04 divided by 6. Oops, 0.04 divided by 4, I mean. Add 1 to it. Take it to the power of 4 times 6, which is 24, and times that by 5,000. 6348.67. See, we're making more money here. The more times it's compounded, the more money I make. Next one is compounded monthly, so 5,000. 1 plus 0.04, there's 12 months in a year. There's my formula. Hopefully you got the hang of plugging it into your calculator at this point. But we'll do it again. 0.04 divided by 12. Add 1. Take it to the power of 12 times 6 times by 5,000. I get 6353.71. One more time. This time, same information, compounded daily. So 5,000, 1 plus 0.04 divided by 365. 365 days in a year. So 365 times 6. So again, you start with 0.04 divided by 365. Add 1. Take it to the power of 365 times 6. Then times by your initial amount, 5,000. And I get 6,356.16. Oops. So the more times it's compounded, this was 1 time per year. Now we had 365 times per year. The more time it's compounded, the more money you make. Graphing with E, you're going to do literally the exact same thing you did before. Domain is all real numbers. Range that has that +1 there, so it's going to be greater than 1. For my XY chart, this time I'm just using my calculator because I'm using E. So when I go to do this, I do 2e to the power of -1 plus 1 gives me 1.73. Do the same thing. This time, instead of -1, it's going to be 0. Gives me 3. This time, instead of 0, it's 1. Gives me 6.43. And then one more time, gives me 15.78. Ooh, that's large. So when I have my XY chart, I go -1, about 2. 0, 3, 1, almost 7, and there you go. Just like the other ones, except this time instead of being a number, it's just E, which is right in your calculator. Last part, compounding continuously. So we had 2 formulas here. We had this one from up here. This is if it's compounded annually, quarterly, monthly, daily. Anything but continuously would be PERT. PE to the RT. Same thing happening here. P is the amount of money I'm putting in. R is my percentage, my rate. And T is time in the bank. Same meanings as the other one. So you deposit $4,000 in an account that pays 6% in annual interest. Compounding continuously means I'm using PERT. What is the balance after 2 years? So $4,000 is put into an account. My rate is 0.06 after 2 years. This one's a little bit nicer in your calculator. You literally just plug in 4,000 e to the power of 0.06 times 2. And you get 4509.98. Again, if you're having trouble with your calculator, please come ask me. Deposit $13.50 this time. And an annual percentage of 0.037 because I moved that decimal place 2 places. And this time it's after 4 years in the bank. So when I go to do this, 1350 e to the power of 0.037 times 4 gives me 1565. 1565.34. If you're using continuously, use PERT. Anything else, you use that formula.